Hello. In the last module, we looked at containers and how they're useful and becoming more popular when it comes to containerizing and deploying our applications, along with the benefits that containers offer over traditional application deployment. An overview for this module. First, we're going to take a look at traditional application load balancing and how we've been using load balancers to deploy and service our applications up to this point. We're going to cover a couple basic theories that are important to know when it comes to putting Kubernetes together. Then we're going to take a look at the various components that make up Kubernetes and how they all work together. We're going to talk about what a node is and how it is useful and used in Kubernetes. Then we're going to talk about pods, what a pod is, what it's made up of, and how it communicates with things like the node and various pods within our Kubernetes cluster. We're going to look at deployments, which is how we actually deploy our containers to various pods that live on top of the nodes. Then we're going to look at services. Services are going to be how we expose our application to the outside world for end user consumption. We're going to cover our lab setup and some various other places you can go to continue learning about Kubernetes and orchestration. And then we will cover a summary of everything that we've gone over. This is very important because Kubernetes and orchestration is very cutting-edge technology, and it is becoming a more popular way for us to deploy our applications. So it is great that you even have the opportunity to touch and to use Kubernetes in this program. By now, some of you may be familiar with the term container orchestration, which I hope you will have a better understanding of by the end of this lecture. So now let's look at traditional application load balancing and how we've been using it to deploy our apps. Here we have traditional application load balancing and a diagram of what that looks like. It consists of a couple things. One of the biggest that you may not be familiar with is the load balancer up to this point. So what is a load balancer? A load balancer is a networking device, so it handles all basic routing and switching, as well as load balancing, and depending on the load balancer, many of them offer additional modules such as web application filtering, security, and firewalls. There's a couple different load balancing methods that you would use when actually configuring your load balancer. Essentially what you do is you have all these apps that sit on top of guest OSs, and these would be virtual machines sitting on top of a type 1 hypervisor. They're connected to a data center switch, which is also connected to the load balancer. The load balancer keeps a pool of each server that contain the application that's supposed to be load balanced within the load balancer. So the IP actually sits right here on the load balancer. When you connect to the application, you are not connecting directly to the server. You are connecting to the load balancer, and then the load balancer proxies this information to the server for you. You have least connections to where it would connect you based on how many servers have the most connections and how many have the least. You have a round robin where it could go from this server, then to this server, then to this server, then this one, without paying any attention to how many connections are on each server. And then you even have ratios where you might say we want this server to get 1 connection per every 3 that this server gets. Why do we do this? It allows us no application downtime, as we can take the servers in and out of the pool on the load balancer to conduct things like application upgrades, maintenance on the guest operating system, and maintenance on the type 1 hypervisor. Or if there's a fault, we can take it out of the load balancing pool, replace the server, and then bring it back up in the load balancing pool when it's ready. What different things can you load balance? Pretty much anything. The most common thing is HTTP web applications, but you can also load balance things such as DNS, email, NTP. Almost anything can be sit behind a load balancer, but it's important to know that from the end user or the client's perspective, you are connecting to a single IP on the load balancer, not connecting directly to the servers. When we look at a traditional load balancing network, we're going to have a load balancer with an IP address here on the front end. This is typically called a virtual IP, or VIP for short. On the load balancer, we are going to have a server pool where we will define server 1, server 2, and server 3 in our pool. On the back end, we will have server 1, server 2, and server 3. So in a round robin style, the client makes a request to the VIP, and the load balancer proxies that information to the server. So as more connections come in, it continues to proxy the information to each server, and then the server responds back to the load balancer, which then responds back to the client. There are other setups that you can use in more complex configurations, but I think this is the best just to get the understanding of a load balancer and how it works. So if this server ends up having a problem, whether it errors out or the hardware goes bad, it goes down, the load balancer detects it, takes that server out of the pool, and then just proxies the information to server 1 and server 2. When server 3 is restored, it adds it back to the pool and continues making requests. So to the end client, nothing seemed awkward or out of place. The application was able to remain up even though we lost a server. This also works for application updates and maintenance on the servers, as we can take servers in and out of our pool manually to perform the updates and then add them back in once the updates are complete. A couple important theories for us to know are APIs. APIs are used very heavily in Kubernetes to communicate with things such as the nodes, the kubelet program running on the nodes, the proxy server, and then all the various managers that take place within Kubernetes. You should have learned about some of these other ones in some of your previous classes, such as DNS, proxy, NAT, and SNAT, but I will go over some of these very briefly. These are showing up because they are not going anywhere, and it is important that you commit these to memory. That is the reason they keep coming up, because they are used so often, and it is important to know the details of some of these technologies. At this point, you should be pretty familiar with APIs, so I'm not going to spend much time on that. You should also be very familiar with DNS, domain name system, which is how we resolve names to IP addresses amongst a few other things, but the biggest thing to remember is that it does resolutions of things like names to the IP address. A proxy. We saw in the traditional load balancing network that the load balancer proxies the information from the client to the individual server. This does not always need to be the case. Really, a proxy can be anything that takes information and relays it to something else. It could be a firewall. One of the most common use cases you may read in things such as A+, Network Plus, and Security Plus books is using a proxy server to communicate with things on the internet. The proxy server takes all the requests from all clients from within the organization, looks at them, sends them to the internet, then the internet sends it back to the proxy. The proxy can then take an additional second to inspect it, make sure nothing malicious is getting through, and then send the information to the client. That is all a proxy does, is it takes information from one, sends it to the other. In your Cisco courses, you should have been introduced to NAT, or Network Address Translation. You most commonly see this in enterprise networks at the edge of the network, where we are connected to the internet. And we have either a firewall or a router. That takes all traffic from the organization and it NATs it to a public IP. Private IPs fall in a few different ranges. These ones you are probably familiar with. If the public internet receives anything in any of those three ranges, it will simply discard it because it recognizes it as a private IP address. That is why your firewall needs to NAT your private IP addresses to a public IP address. This is just one that I'm going to use. This is Google's DNS servers, very common ones to commit to memory. But you could NAT it to a public IP address, and then once the internet receives it, it will take the traffic. If it receives a source inside of these private ranges, it simply discards it. The firewall or the end device keeps a record of everything that has been NATed to that public IP, so when the traffic is returned from whatever source it is that you are trying to hit on the internet, it will re-NAT it back to your private IP so that it can get to your computer within the organization. And then you have SNAT, which is source NAT, or source network address translation. Here we were seeing all of the different clients in our organization were NATing to one thing to get out onto the public internet. But what if we wanted to do the opposite and we had everything on the internet that wanted to communicate with, let's say, an app deployed on a Kubernetes cluster that is exposed via a service. So here's the IP address. What SNAT would allow us to do is all these different public IP addresses are coming and being consumed. It would translate their addresses to either a public or a private IP address so that the app is only receiving from one IP address. So the sources are NATed to the application, making it source NATed or SNAT. Here we have the various Kubernetes components. As you can see, we've got the control plane that keeps things such as the Kube Controller Manager, the Cloud Controller Manager, the Kube API Server, the Etsy Volume, and then the Kube Scheduler. Here we have 3 nodes. Each of them has the Kube proxy installed on it, as well as kubelet services. And then we are connected out to our cloud right here. What the control plane does for us is it manages all of the decisions for our cluster. It also monitors, detects, and responds to various events that happen within our cluster. The Kube API server exposes the Kubernetes API. The Etsy volume is a backing of key value stores for all of our cluster data. The Kube Scheduler looks for new pods with no nodes assigned to it, and it will assign a node to those pods. The Kube Controller Manager controls the nodes, replications, endpoints, service accounts, and token controllers. The Cloud Controller connects your Kubernetes cluster to your cloud provider's API so that you can expose your service to the cloud provider. Kubelet is an agent running on the nodes, and it makes sure containers are running in the pods. And then the Kube proxy, this is your networking portion for the nodes. It is your network proxy on each node. It has your Kubernetes services concepts in it, all of your network rules, and allows for communication between the pods. So what are your nodes? Your nodes are going to be your workers. They could be physical machines or they could be virtual machines. But it is important just to know that these are going to be essentially your end nodes within the cluster. So you can have one or you can have many, and they are all going to be controlled by the master. They contain different services. So you can see we've got Kubelet installed, and then we also have our Docker engine installed on the node. And they are all managed by the control plane. We have 3 different types of node addresses here. You have the host name as it was reported by the node's kernel operating system. The external IP, which is going to be the routable IP that can communicate outside of our cluster. Kubernetes is all self-contained, so much of the things in Kubernetes do not have access or communication with the outside world unless it is communicating on things such as a service or an external IP. Otherwise, it uses the internal IP, which is only routable from within our Kubernetes cluster. For our nodes, what is a node? A node could be a physical machine or a virtual machine. You will have multiple nodes in a typical Kubernetes cluster. Which are all controlled by the master. Each node, we will simply say these are Linux machines. They have Docker installed on them, and they have Kubelet installed. With kubelet, they also get the kube proxy. On the master, we have the kube API server, which communicates to both kubelet and the kube proxy to handle things such as scheduling, monitoring, and maintenance. So the master would control each one of our Linux machines. And again, these can be virtual machines or they can be physical machines. They have to have the necessary things installed on them in order to communicate with the master, and then the master can add them to our Kubernetes cluster. What is a pod? By definition, straight from Kubernetes website and the documentation, pods are the smallest deployable unit of computing that you can create and manage in Kubernetes. They share a common namespace and file system volumes, and we'll look at more of those when we go into our demo and when you do your lab. They contain containers. It can be a single container or multiple. So in our example right here, you can see we have the node with the node's IP address right here, and then we have our pod. Our pod contains 2 containers in this example. They share a common volume, and then the pod itself has its own IP address. The pods run on top of the nodes, which are the workers. A Kubernetes pod. Let's say we have a single node, as you will have in your lab for this module. We'll say it's a Linux node. Controlled by the master. And the master says we want to create a deployment which will then deploy a pod to the node, and the pod can contain 1 or multiple containers, however many that it needs in order for the application to actually run. All the containers share a pod namespace, and you will see examples of that in the demo and in your lab. And then they share a common volume, filing system, storage, however you want to put it. You can access each container individually, as we will see in the demo and in the lab. Through our deployment, we specify what these containers need to actually be in order for it to work. And the pod is given its own IP address that is not routable outside of our Kubernetes cluster without a service. So the node has an IP address of its own, considering it is its own virtual machine or its own physical machine. It is also going to have its own name. And then the pod is deployed on top of the node with its own IP address and name. And again, it can contain 1 or more containers that all share the namespace and the volume. A Kubernetes deployment. Deployment is the de facto way that we are actually going to deploy our containers and our pods to the Kubernetes cluster. The deployment lives on the master node, which is going to do all of our scheduling for us, look for nodes that do not have the pods deployed, and deploy the nodes, or deploy the pods to those nodes. It declares which image is going to be used for the container. It also does replication of the pods, which is called scaling your app, in which you create more pods as your application grows and is consumed more, or as it becomes less consumed, you can scale up or scale down your deployment. It is also very useful for updates and rollbacks of our application. So if we deploy our app to our staging environment, which would be our final test stage before we roll the app to production, we find no problems with it and we roll it to production. Later we find that there is a problem that was missed. We can simply just roll back to the last version of our deployment, and the rollback is seamless. It also provides us a history of our deployment and which images were used on which containers and what the differences were, and it allows us to scale up or scale down our deployments as needed. When we create a service, what we are doing is we are exposing our deployment, our pods, our application for consumption to the outside world. There are 4 types of services you need to be familiar with: cluster IP, node port, load balancer, and external name. Here you can see we have 2 nodes running with a pod on each node, but the service itself spans across both nodes and is given a service IP. The cluster IP is what is the default type of service in Kubernetes. It is only reachable from within the cluster, so cluster IP does not expose it to the outside world. Node port uses the node IP with an assigned static port to it, which then would be accessible to the outside world via the node IP and the static port that was assigned. The most common one is probably this load balancer service, which connects externally using your cloud provider's load balancer, or if you have a load balancer on-prem, connects it to the load balancer and makes it accessible from the load balancer via an external IP address. And then the last one is external name, which does not use the kube proxy that is on the node. It maps the service to contents of the external name using DNS CNAME records. For deployments and services, let's go ahead and put everything together. So we will say that we have a 3-node Kubernetes cluster. All being controlled by the master. We then create a deployment on the master. Specifying what images we would like to use in our deployment and how many replicas of each pod we would like. The master sees that there are no pods running on the nodes. It chooses a node and deploys the pod with the container and its own IP address. Keep in mind that the nodes also have their own IP address. We decide to scale up our deployment because one pod does not suffice. It's not enough. If this pod goes down or this node goes down, we lose our application. So we decide to scale it up to 2 more replicas. When we scale our deployment, the master looks at each node, sees there's no pods running on it, and deploys the pod, an exact replica to each node. So now we have 3 nodes, each with a single pod on it, each with their own IP address space that is not routable from outside of our cluster. To make it serviceable, we need to deploy a service or add a service to our deployment using one of the following methods. Cluster IP does not make it actually serviceable outside of the cluster, but it is serviceable from within the cluster, and you will see an example of this in your lab. What the service does is it runs across all three nodes in all three pods, and it acts very similar to a server pool that we saw on a traditional load balancer. Via cluster IP, it would give it an IP address that is only routable within our Kubernetes cluster and can be serviced on that IP address. Node port, it would take the node's IP and assign it a static port to which it is then accessible via the node's IP address and the node's port from outside of our cluster. The most common method you will probably see is this load balancer method, which then exposes it. This can be in the cloud or on-prem to a load balancer VIP, which it can then load balance between the three pods, much like in traditional load balancing, only these are a lot more easily scalable, lightweight, and offer self-healing, because in our deployment we have specified we want 3 pods. Well, let's say for whatever reason this pod malfunctions and goes down. The master would detect it, it would delete this pod, the deployment would see I only have 2 pods in my deployment, but I have specified 3. So upon deletion of this pod and it realizing that it is now down 1 in the deployment, it simply creates a new one automatically, making it self-healable. External name, remember, no proxy is used in external name, and it maps the service to the contents of the external name using a DNS CNAME record. However, this one is not very common, so I'm not going to go into too much detail about it. However, you should be familiar with DNS and the CNAME record from your A+ classes. For our lab setup, we are going to be using Minikube, which I have pre-installed on the SDN VM that you can download from my Google Drive. What Minikube allows us to do is it deploys a single virtual machine, which is going to be our single node cluster on top of our host SDN VM. It is very important that you understand that the installation and setup of Kubernetes is not important. As you can see, most deployments have multiple nodes, and it can get rather complex adding all of those nodes to your cluster just for a lab environment. It is more important that you understand the theory behind Kubernetes, the CLI, and how to use it. One of my favorite learning tools out there is to use Google's Cloud. I have found it the most user-friendly and works best with Kubernetes. You could set up a 3-node cluster in a matter of minutes on Google Cloud and use that to expand your skill set, as well as any of the tutorials that are available on the internet. Upon signing up for Google Cloud services, Google allots you $200 in free services to use. And if you are just using it for training purposes, I highly doubt you would use up that entire $200. I left a cluster running for over a week at one point, and it did not even put a dent in that $200. Plus, Google does not ask you for any type of payment information. So once you run out of that $200, they will ask you for your payment information if you wish to continue using the services. Additionally, there is the Kubernetes Playground, Play with Kubernetes online that you can access via a web browser. For this demonstration, I'm simply going to walk through some of the basic Kubernetes commands that you will use, their use cases, as well as Minikube. The first thing I want to do is make sure that I have everything necessary installed. I am using the SDN VM that is available on my Google Drive for download. If you need the credentials and if you choose to use this and need the credentials, please reach out to me and I will give you the username and password. The first thing I want to do is verify that I have Docker installed. I do. I want to make sure that I have kubectl installed. I do. And now I want to make sure that I have Minikube installed as well. I do. I am now going to start the Minikube VM, which takes some time to boot up. So I will fast forward through this section while the Minikube VM is getting ready. The command to do that is going to be Minikube, and again, always remember to use your help options if you don't know something. So here it gives me all my options for my Minikube commands. Additionally, you can always use the manual pages specified with man and then the command that you would like to enter. So I can do a man and less. And here's the manual page for the less command. So I can see from my options here that I've got some basic commands and I want to go ahead and start a local Kubernetes cluster. So I'm going to use Minikube start. What this command is going to do is deploy a virtual machine using VirtualBox's Type 2 hypervisor without the graphical user interface of VirtualBox. So it is going to deploy automatically a virtual machine and give us a cluster that contains one node that is our virtual machine. So I'm going to run Minikube start and let Minikube go ahead and deploy, and I'm going to fast forward through this section. Now that Minikube is up and running, I'm going to issue the Minikube dashboard command to pull up my GUI web-based dashboard for Minikube. If you've ever visited Google Cloud before, you will see that this looks awfully similar to the Google Cloud platform. And here you can see we have the service Kubernetes running, and it gives us a little overview. You are welcome to come in here and look around. Here we have our node Minikube that is now up and running, as well as our different namespaces and our cluster roles. I'm going to go ahead and minimize this. Just know that that is available for you to use. Actually, I'm going to close that. That is available for you to use as you work through your lab. First thing I'm going to do is I'm going to go ahead and do a kubectl cluster info to get all the information on our Kubernetes cluster. And here you can see the Kubernetes master is at 172.17.03, as well as our kubedns, because we only have one node running, considering this is a lab environment. You can issue the kubectl command along with help to also see the different options that you have with the kubectl command. It is very similar to Docker in that kubectl needs to be entered for every command that you want to use in Kubernetes. A very common one is the get command, which will give a brief output of our cluster or anything that you specify to it. So I can do a kubectl get help to get all of my options for the get command. Let's see how many nodes I have up. So I'm going to use get nodes. Here you can see I have one node, Minikube, ready, and its role is the master. To get more information, you can enter kubectl, describe, also with the help option to see your different options that you have. Here I want to see more information on my nodes. So here is all the information on the one node that I have running. Here's its name, its role, and here you can see its internal IP address, as well as any events that have happened on this node. Let's see if I have any pods running. So I'm going to do a kubectl get pods. I do not. Let's see if I have any deployments. I do not. If I don't have any deployments, I shouldn't have any services, but let's just do it for good measure. Ah, I do. I've got my Kubernetes service that is running on my cluster IP at 10.96.0.1. This is the only service that is running because it is the Kubernetes service that is exposing the Kubernetes API. Let's go ahead and create our first deployment. And for this deployment, I'm going to use the image that we created at the end of the Docker lab, which I have taken the liberty of posting on the Docker Hub, that image. So in order to create a deployment, it is going to be the kubectl create command. And again, you can look at the help to see all the different things you can create. But here I would like to create a deployment. So I'm going to issue a kubectl create deployment. I'm going to give it a name, and this is going to be kube demo, and then I'm going to specify which image I would like it to use, and by default Kubernetes is going to look at the Docker Hub, so I'm going to give it the full name of my image that is published on the Docker Hub so that it pulls down the correct image. And here you can see my deployment in kubedemo was created. So I will issue a kubectl get deployments. As you can see, I have one deployment now, but 0 pods are up and ready. 1 is set to be my replica. So let us issue the kubectl get deployments again. You can see it is not ready yet. This is because it is pulling the image from the Docker Hub and deploying the pod to the node. So let's check out the status on our pods and see if we have any running yet. We do not. It appears that it has an image pull back off. Ah, I see what I did. I had a typo in my image. I left out an S, so it cannot find the image. So let's do a kubectl get deployments. nothing is ready. So rather than just deleting the pod, a deployment is how you deploy pods and how you delete them. So I'm going to simply come in and delete that deployment. And I have to give it the full name of the deployment. And here you can see I should no longer have any deployments. And they are gone. Let's see if I have any pods. I do not. So let's issue our create deployment again, and I will fix my typo. You can see the deployment was created. I do not have one ready yet. Let's check on the status of the pod to make sure that that is all working. It's creating the container. This is a better sign than the image pull back off, which was stating that it could not find that image because I had a typo in the name. It's still not ready. While it is still getting ready, let's go ahead and describe our deployment. And here's all the information on our current deployment. You can see it has given it a name in the default namespace. It has given it a label of app cube demo. Replicas, 1 desired because that is all we have specified right now. Here you can see the pod template where it is giving it the label app cube demo, and here it is specifying which image to use inside of the pod. Let's go ahead and see if our pod is ready yet. It is still creating the container. This is because this is a fresh instance of the SDN VM, so it's got to pull down the container, but we can still do a kubectl describe pods, and let's go ahead and describe this pod. As you can see, it gives a lot of information. Here's the node that it is assigned to. It is assigned to Minikube, and here's the IP address. This is the default namespace that we were talking about, using this name that it assigned to it. So even if I had multiple containers in here, they would still only be using this single namespace, which would be the namespace of the pod. Here's the labels that our deployment created for it automatically. And down here, you can see the containers, the image that it specified. It is still creating the container in a waiting state. Here you can see down in events, it is still pulling the image. It is more than likely just taking a long time because I am running the SDN VM on VMware Workstation. Let's see if the pod is ready yet. It is. So now the pod is up and running. Let's look at our deployment again. 1 of 1 up and ready because we have specified 1 replica. Let's describe the pod again. There you can see the IP address of the pod. Let's see if we can ping the pod. I cannot. This is because Kubernetes is self-isolated and I have not assigned the pod a service yet to communicate outside of the cluster. Let's go ahead and create a single service. I am going to do the load balance service, and we do that with the kubectl expose command and specify the deployment. So here we are going to do kubectl expose deployment kube demo. The name of the service is going to be kube demo LB for load balancer. And then the port I would like it to be running on is 80, and I would like to target port 80 on the container because that is the port that is exposed. And then the type of service is going to be load balancer. As you can see, service kube demo LB is now exposed. So we will run the kubectl get services command again, and you will see we now have a service for our pod with a type of load balancer. Here's the cluster IP address. In a normal environment where you would be using an actual load balancer or a cloud provider, you would then be getting an external IP address and your application would be ready for consumption on the public internet. Let's go ahead and describe our service to see all the information. There you can see the IP that it's running on. Port is 80, target port is 80, and then it even gives us the endpoints and the node port. What we need to do now is, since this is a lab environment and it is a virtual machine Minikube, we have exposed the pod to Minikube via the load balancing service, so we need to use Minikube to actually consume our application. So I'm going to run the command minikube service, and then I'm going to specify the name of my service. Here you can see Minikube is opening a browser, and I can see my web page, welcome SDN world. This is an example of an API service with Flask. Here you can see the IP and the port that it is using as specified down here. So just to verify that I can in fact hit it again, I'm going to curl that IP address, specify the node port, and I'm going to see if I can reach my API on the Flask application. I can. Let's go ahead and scale up our deployment, because right now we only have one replica of it that is actually running. So I'm going to enter the kubectl get replica set command, and you can see we have one desired, one current, and one ready. I'm going to do a kubectl get pods to see that we only have one pod up and ready. So now I'm going to scale the deployment with the scale command. And then I'm going to specify that I want 5 replicas made. This should take much less time because the image is now already on the Kubernetes cluster, so it doesn't need to freshly download that again. Let's run the get deployments command again to see the difference. Now you can see I have 5 ready, 5 available, and they're all up to date. So if I run my get replica sets again, you will see I have specified 5. If I run my get pods command, you will see I now have 5 pods up and running. One that has been running for 8 minutes 51 seconds and the other for 34 seconds because they were just created. Let's verify that I can in fact curl my app again. Might help if I use the correct path. And there you can see I now have 5 pods running, and I can get specific information on each pod by issuing my describe command. Let's look at my services again. And you can see I'm still exposed on my load balancing service. What we are going to do now is clean up our demo. So I'm going to delete my service. And you can see it was deleted. So if I run my get services command again, you can see the service was deleted. If I run curl again, you can see it failed because the service is no longer there. But if I do a kubectl get pods, all my pods are still up and running. In my deployment, I still have 5 of 5. To get rid of my pods, I'm going to now delete my deployment. And I'm going to run my get pods command again, and you can see they are now terminating. And you can see now they are all gone. I am now back to the default. So I am going to issue a minikube stop command to stop minikube. After minikube has completely been stopped, I'm going to delete that instance of our lab. So the next time I start minikube, I will be working with a fresh instance of minikube. In summary, we have looked at traditional load balancing, a few theories to know and that are important when it comes to Kubernetes. We've looked at what a node is and how it participates in our Kubernetes cluster. We've looked at pods, what they contain, and their purpose. We've looked at deployments and learned that this is how we are actually going to deploy our containers, our images, and our applications to our Kubernetes cluster. We've looked at services, which is going to be how we expose our deployment or our pods, our application, however it is that you choose to word it. Then we've gone over our lab and a brief demo of Kubernetes. If there are any questions, I encourage you to direct them towards the discussion board where everyone can participate and ask the questions together. I really hope everyone enjoyed this lecture, and I hope you enjoy this module's lab on Kubernetes. Thank you.